Hi, welcome to MACSGATE. Let us continue the subject DBMS. In DBMS, we are discussing about normalization. And in normalization, we have completed functional dependencies and uses of functional dependencies. Now, let us continue the concepts of normalization. In this session, we are going to discuss what is decomposition and what are the properties we need to consider when we decompose a relation. So, let us start the session. Decomposition. What is a decomposition? Suppose I have a relation with some five attributes. Then, depending on the requirement, sometimes we need to divide this relation into two tables. Actually, this is a relation or a table in which we have five columns. Fine. Now, this table may be divided into two tables or three tables. That depends on requirement. Suppose I divided A, B, D, and the second table is B, C, E. So this is my first table and this is my second table. Right? So we divided the given relation into two tables. And now the first point is when we decompose the table, we make sure that they both have a common column. They both have a common column or common attribute. Because we need a common attribute. Sometimes again we need to rejoin these two tables. Then in such case, this we need, or a common attribute will be used to link these two relations. Right? So that is the first one. Now the question is, whenever you are decomposing a relation R into two tables, R1, R2, what are the properties we need to keep in our mind? Okay, so that is what we are going to discuss now. Properties of the decomposition. The first one is lossless and the second one is dependency preserving. So what is the meant by mandatory? Suppose I am dividing a relation into two tables, R1, R2. If this decomposition does not satisfy this property, then we are not allowed that relation to be decomposed into R1, R2. So whenever this property has failed, we will stop the process of decomposing. Then coming to the second one, dependency preserving. That is optional, sir. Even the decomposition does not satisfy this property, depending on the requirement, we will proceed. So that is the meaning of these two, sir. In this session, we are going to concentrate on lossless decomposition. What is the meaning of lossless? That means whenever we decompose, there is no loss. That is the meaning of lossless. Now, how to identify the loss? That is the main story. How to identify the loss? For that, we need some small concepts from relational algebra. So let us start with those two. The first one, cross product, and the second one is join. First, let me give the cross product in mathematics. Sir, suppose we have three elements in A and two elements B. Then what is A cross B, sir? For that, first we consider the first element in A. For that, we map each and every element of the second set. Similarly, consider the second element of A. Again, map each and every element of the second set. Similarly, the third one, C1, C2. Now, this mathematical set can be considered as a relation. Suppose A is my relation in which I have only one attribute. Okay, let us assume the attribute name is X. There I have three values A, B, C. Similarly, B is a relation in which also I have only one attribute. Let us name it is Y, and I have this one. Then whenever you form A cross B, what we do, sir? First we consider the first row of the table. So what is the first row of the table? Now let me represent this also in terms of the relation. So the A cross B is a relation. A cross B is a relation which consists of the attributes from first relation and the second relation. In this case, I have only one attribute from the first relation and one attribute from the second relation. Then how to form the records of this relation? Consider the first record. What the first records are? A. Map this A to first record and second record of the second table. What you get? A1, A2. Hope you understood it. Now let us consider the second element of the first table. Again, map these two to these elements. So B1, B2. Similarly, the third one. Right? So C1, C2. That's it. So like cross product in mathematics, we can apply cross product to the relations. Now in this example, I have only one attribute in the relations A comma B. Suppose I have a relation in which I have two attributes x comma z. Let us continue the values as A10, B20, C10. Let's consider only these relations. For B, let us consider two more attributes. Suppose this is Z, this is Y. Okay. So let us have only two records and let us continue 10, comma 20. Fine. Now, if we form the cross product, the resultant will have four columns, two from the first table and two from the second table. Now consider the first record. What is the first record, sir? A10. This is mapped to the first one as well as the second one. So A10, 10, 1. A10, 20. So we completed the part for first record. Let us consider for second record. B20, what is the first one, sir? 10, 1. B20, 22. Then let us consider the last one. C10, 10, 1. C10, 22. Like what we have done in the case of cross product of the mathematics sets, we have done the same story here. So that is about the cross product. Then what is join? Join is a, simply you can say join is subset of cross product. That means cross product will consider all the possible rows for A cross B. When coming to join, it will filter some records. So it will filter some records. Then what are that? So let us consider the first one. Join will consider the rows in which the common columns are having same values. The common columns, yeah. Sorry, sir. The common column should have same values. Suppose I consider the first one. These two are having same values. So we will write it. A 10, 10, 1. What about the second one, sir? Will you write the second one? These two are not same, sir. So we don't write it. Then what about the third one, sir? A 20, comma 10. This is also not equal. We don't write it. What about next one? 20, 20. They are same. So I will write 20, 22. What about the last one? These two are same. So we can write C 10, 10, 1. Can we write the last one, sir? No, these are not equal. So we don't write it. So this is the records of join. So join will filter some records in cross product. That's it. What it will filter, sir? It don't consider the records in which the common attributes don't have same values. Hope you understood it. This is about the cross product and join. Now I need the concept of join to discuss the first property, lossless. So I think we are ready to discuss the first property, lossless. Let us consider the decomposition. Okay. Suppose I have a relation. I have a relation R. Okay. Now let us decompose this table into two tables. These are the two tables. Assume this is my R1. This is my R2. In R1, I have considered the attributes A, B, C. Right? Then in attribute in relation to, we have considered two attributes. Fine. Now what we do is we rejoin, that is apply join of R1 comma R2. If we get the same table R, there is no loss for decomposition, because whenever I don't want the decomposition, I can go back to the original state. So that is the meaning of lossless. So now let us do the join of these two and verify whether we are getting the same original table or not. So let us consider the first one, sir. Consider the first record A1, B1, C1. I need to map these three. Among these three, what I should consider, sir? I need to consider C1, C1. Fine. C1, C1. This I should not consider because the common column don't have same values. So A1, B1, C1. Since both are same, they return only for one time, sir. Fine. B1. Now I don't consider the second map. Right? A1, B1, C1. Again, what is the last one, sir? B3. Or let us do one thing, sir. To have more clarity, let me write like this. Let us write C for two times so that you get clarity. So A1, B1, C1. What is the first map, sir? C1, B1. The second, I don't have any map C1, C2. They are not same. So I don't consider it. A1, B1, C1. It was matched with third row. C1, B3. Then what about second record? This is our second record. And it is having matching only to one value C2. So that means I can write A2, B2, C2. C2, A2. That's it. And what about the last value? This is having matching with the first row and the last row. So let us write those. A1, B3, C1, C1, D1. A1, B3, C1, C1, D3. Hope you understood it. Right? So now if we forget about this C, just for our understanding purpose, we written for two times, right? Fine. Now, is this result same as the original one? Result and the original table are they same, sir? No, they are not same. They are not same. A1, B1, C1, D1. This is original. I have in my original table. What about second one? A1, B1, C1, D3. It is not there. So it is extra or some suspicious, which is not in original. What about the second one? A2, B2, C2, D2. Yes, it is original. What about third one? A1, B3, C1, D1. It is not in the original. And the last one is original. So if we observe very clearly, we got two extra tuples which are not in the original. So these are called spurious tuples. So this is a technical term we use. Spurious tuples or false tuples. Actually, they are not in the original table because this decomposition is not satisfying the property lossless. We are getting some extra tuples which are not original tuples. So this example is a lossy decomposition. This example is a lossy decomposition. So that's why we don't consider it, because lossless property is mandatory. Lossless property is mandatory. So now let me give one more example so that we can understand what is lossless. Suppose the same relation, this time I divide it into like this. What is the common attributes of V? So this is my relation R1, this is my relation R2. Let us rejoin. Join of R1, R2. So for our understanding purpose, let us write value for 2 times. And sir, this B1 is having matching with first record only. Any other matching, sir? No, this is not matching. Any other matching? No, this is not matching. So I will write A1, B1, B1, C1, D1. That's it. What about the second row? The second row is B2. This is not having matching with first row. As a matching, don't have a matching. So I will write A2, B2, E2, C2, D2. What about the third one, sir? This I don't have a matching. This we don't have a matching. As this is having a matching. Fine. So let me write A1, B3, B3, C1, D3. Am I right, sir? So fine. I think these are the tuples we will get in the join. Now the question is this result is equal to the original table? Yes, of course. So there is no loss. Instead of writing no loss, we will write lossless. So this is the meaning of lossless. Now the question is how to verify lossless. Sir, here in this example, the first point, we know the records. The second point, the number of records is very less, which is having only 3. Now let us suppose that we don't know anything about the records, or suppose I have millions of records. Then it is not possible to write the answer of the join. It is not possible to write the join of the tables R1, R2. Whenever I have 20 records, 30 records, or millions of records, then how to verify the property of lossless? So to verify the property of lossless, as usually we use functional dependencies. We use functional dependencies. So this is one more usage of functional dependencies. So without knowing functional dependency, it's not possible to learn the concepts of normalization, right? So now let us continue the discussion how to verify lossless by using functional dependencies. Lossless decomposition. A decomposition will be lossless if the common attribute is a key in one of the tables. If the common attribute is a key in one of the 2 tables. That means previously in the example, this is my relation R1. This is my relation R2. To have lossless, what is the common attributes are? Common attribute is P. So I need to verify whether B is a key. B is a key either for R1 or for R2. One of them is enough, sir. Even both of them are true, I don't have any issue. So it will be good, right? So let us do it. If you write in technical terms or notations, suppose a relation R is decomposed into R1 and R2. Then the decomposition is lossless if R1 intersection R2. So the meaning of R1 intersection R2 is common attribute. Common attribute. So with the help of common attribute, I can get R1. What does it mean? I can get the values of attributes of R1. What does that mean, sir? This is the key for R1. Similarly, the second one. So this is the way we need to verify. Whenever they are given two relations, first we need to identify what is common attribute. The second step is whether it is a key or not. We know how to find a key. How to find a key, sir? Suppose this is my common attribute. Then first I find the closure. We find the closure. Suppose this contains all attributes of R1. Let me write it. All attributes of R1. That is fine. Or the closure should contain all attributes of R2. Any one of the condition is enough, sir. Any one of the condition is enough. So this is the way we are supposed to verify the lossless property. Okay, let us do some examples so that we can understand the procedure very clearly. Suppose this is my relation with three attributes A, B, C, and I have two functional dependencies A plus B, B implies C, and the relation was decomposed into R1 with the two attributes AB, R2 with the two attributes BC. Now the first step, they already given, sir. What is R1? A comma B. What is R2? B comma C. The second step, R1 intersection R2. Or simply we can say what is common attribute. What is common attribute? What is common attribute in this example, sir? In this example, it is B. Now, what is the third step? Closure of B. Closure of B. What is closure of B, sir? With B, I can get B. That is trivial. I have a functional dependency, B goes to C. We have a functional dependency, B goes to C. That is what they given here. So with the help of B, I can get C. Anything else possible, sir? No. Anyway, we got all the attributes of R. What does it mean? B will imply R2. Or you can say B is a key for R2. So since it is a key, there is no loss. Or you can say lossless. Hope you understood. What are the main two steps, sir? Identify the common attribute. The second step is find the closure. If the closure contains all the attributes of either the first relation or the second relation, then it will be lossless. Am I clear, sir? Let us do one more example. Suppose we have a relation A, B, C, D with four attributes. Then functional dependencies. A implies B, C implies B, C implies D, A implies D. And the second step is R1 intersection R2. Our intention is the common attribute. What is common attribute, sir? C. Now find the closure. Find the closure of C. What is the closure of C, sir? Let us do it. With the C, surely we will get C for R2. Since it is a key for the second relation, there will be no loss. So you can conclude it is lossless. Hope you understood it. Let us consider one more example. I have a relation with 6 attributes A, B, C, D, E, F. Right? Now the functional dependencies are A implies B, C implies EF, B implies D, D implies A. What are the relations they given, sir? The relations are, the first relation is R1 with A, B, C. What is R2? B, D, F. What is the first step, sir? The first step is identify the common attribute. What is R1 intersection R2? The common attribute B, E. Yes, I have it. Find the third step. Find the closure of B. Find the closure of B. What is closure of B? With B, trivially you can get B, right? Anything else possible, sir? Yes. With the B, you can get D. Yes. With the D, you can get A. Yes. With A, you can get B. B, I already have. Anything else possible, sir? No, not possible. Now the question is, this not contains R2 completely. Am I right, sir? Because what is R2, sir? I have B, D, F. It was missing. Even it not contains R1. What is R1, sir? A, B, C, E. Right, sir? So I think we miss C. That means B is not a key. B is not a key for R1. Similarly, B is not a key for R2. Since no one of the condition is not true, it is loss. Hope you understood it. So this is the way how to verify whether there is a loss or not. In all these examples, we considered only 2 relations. That means the original table has decomposed into 2 relations. Now the question is, whenever the relation is decomposed into 3 tables, what is the procedure we supposed to do? Okay, I think we have one more example with 2 tables, sir. Let us do it quickly. So what is the first step? R1, A, B, C, R2, D, E, F. The second step, R1 intersection R2. What is the common attribute? The common attribute is B. Right? I think every time we are getting B, sir. Fine. So let us have B. What is the third step? Find the closure of B. What is the closure of B in this example? B implies B, fine, sir. I think B will imply D. Yes. D will imply C. So D will imply C. Then CD implies C. Yeah. Then E implies A. Then A implies F. I think we got all attributes. We got all attributes. That means the closure contains R1, the closure contains R2 also. What does it mean, sir? B is a key for both tables. B is a key for both of the tables. One of them is enough. Anyway, luckily we have B is a key for both of the tables. What is our conclusion, sir? There is no loss. Clear, sir? Yeah. Now we have three tables. Whenever we have three tables, what should I do? First, let me give the procedure here, sir. The first case. Suppose all the three having a common attribute. All the three having a common attribute. I have something here. Suppose this is X. Then continue the closure. Continue the closure and verify whether X implies R1 or X implies R2 or X implies R3. The same story, sir, but to happen this one, all the three tables should have a common attribute. Now suppose the second case, all the three tables don't have a common attribute. Okay, then select any two tables which have a common attribute and verify the property. Select any two tables which have common attribute and verify the property. If the property is success, then combine those two tables and again compare with third table. Suppose if the property is not success, go for another pair which have a common attribute. Right, sir? Let me repeat it. Out of three tables, select any two tables which have a common attribute. Verify the property. If the property is true, that means if the property is success, combine it and compare with third table. If the property not success, then consider the second pair. Okay, I will explain case 2 in next slide very clearly, sir. So first let us consider example for case 1. So here the first table is A, C, B. The second table B, C, B. The third table E, F, D. Does we have any common attribute for all the three tables, sir? Yes, of course, we have it. What is the common attribute for all the three tables? D, D, D. S. We have it. So whenever we have a common attribute for all the three tables, so it's not only for three tables, you can consider for 4 tables also. Okay. Whenever we have more than 2 tables, this is the procedure. Now luckily we have common attribute. Find the closure. The procedure is same now. Find the closure of D. What is closure of D, sir? With the D, trivial I can get D. With the D, you can get E. Then with E, I can get D, A. Yeah, yes, I have A. With A, I can get BC. Right? Yes. B, C. Anything possible, sir? No, that's it. So A, C, D, I think it contains R1. No need to wait for the remaining, sir. Just for the sake of completion, I think it contains B, C, D also. But it not contains the third one. Anyway, one is enough. So you can say this is a key. This is a key for R1. This is a key for R2 also as well. Of course, one of them is enough, sir. Therefore, there is no loss. Or you can say lossless. This is the case 1 when all the tables are having a common attribute. Now let us consider one more example in which all the tables not having a common attribute. Let us consider this one. Please observe, sir, all the three tables don't have common attribute. First, let me write it, sir. R1, A, B, C. R2, A, B, D, E. E, F. So what I do is I will consider two tables which have a common attribute. These two have a common attribute, sir. The first step is I verify the property. If this is true, let us assume, I don't know, sir. Let us assume this is true. Then I combine these two, R1, R2. So what I get, sir? A, B, C, D. I compare third table. Now I have only two tables, right? And this is having a common attribute. Again, verify the property. Right, sir? Suppose this has failed. This has failed. So in such case, let me restore the tables again, sir. AF. If this property has failed in this case, then I consider the second two tables, whether they are having any common attribute. Yes. Then verify the property. If the property is true, then I combine these two, R2, R3. If I combine those two, I will get A, B, D, F. Then let us consider R1, A, B, C. Then again verify the property. Like this, we need to select the pair which is having a common attribute. If the property succeeds, then we combine it. That's it. So this is the procedure. We need to do it. So let us do it, sir. So the first we are combining these two. I don't know whether succeeds or not, sir. First of all, what is R1 intersection R2? R1 intersection R2, what is that, sir? B. I think we have two common attributes, right? Yes, AB, AB. What is AB closer? With AB closer, I will get AB. Anything else? With the AB, I can get C. Then with the AC, I can get B. I think B already there, sir. No need to do it. Anything else? With the B, you can get D. Then with the BC, you get A. That was already there. Then any possibility for E, sir? S. With the AB, you can get E. Then with the E, you can get F. Right? Anyway, we got all the attributes. So what you can conclude, sir? AB is a key for R1 or R2. You can write anyone, sir. So the property holds. Since the property holds, what is the second step, sir? Combine these two. To combine these two, R1, R2, A, B, C, D, E. What is the third element? E, F. Now, what is the combination or common attribute for these two? What is the common attribute for these two, sir? I think we have E. Am I right? What is the closure of E, sir? Closure of E is E itself contains, then I have a conditional E goes to F. Yes, you can write. Anything else possible? No. Anyway, this contains R3. Yes, sir. 1 minute, sir. So this contains R3. So E is a key for R3. Hence, it is lossless. Hope you understood it. Right? So let us do one more example on this. Yeah, this is one of the previous questions, sir. We have a relation R with P, Q, S, T, X, Y, Z, W. And the functional dependencies are P2 goes to X, P goes to YX, T goes to Y, Z goes to ZW. Sorry, Y goes to ZW. And they given two decompositions, sir. Just we need to verify both the decompositions individually. The first one, let's consider, sir. Any common attribute for all these? No, sir. We have these two a common attribute. What is the common attribute? PT. What is the closure of PT? We have PT. Then P implies YX. Right? Then P implies YX. Y implies ZY. ZW. Y implies ZW. Anything else possible, sir? No. Anyway, by this time, it contains the second one. Let us assume this is R1, this is R2, R3, R4. So this contains R2. So let us combine R1, R2, PQ, ST, X. Then what is the third table? QY. What is the fourth table? YZW. You can consider any two, sir. I think these two are having common Q. What is the closure of Q? With the Q, I can get Q. Then I have a dependency, Q goes to Y. Then with the Y, I can get ZW. Right? Fine. Anyway, this contains R3. So you can combine R1, R2, R3. P, Q, S, T, X, Y. Right? Now, what is the common attribute, sir? I think the common attribute is Y. What is the closure of Y? With the Y, I will get Y. With the Y, I will get ZW. That's right. Anything else? No. Anyway, we got R4. We got R4. So this is lossless. This is lossless. Hope you understood it. In the same way, we need to verify the second decomposition also. PQS, PX, QY, YZW. Let us consider it, sir. PQS, let us consider it as R1. PX, this as R2. QY, this as R3. YZW, this as R4. Then these two have a common attribute. Okay. P and R1 intersection R3. What is the common attribute? Q. What is the closure of Q, sir? With the Q, I can get Q, comma Y. With the Y, you can get ZW. Then anything? No, sir. So anyway, this contains R3. This contains R3. So let us combine R1, R3. You get PQSY. And I have R2 TX. And we have R4 YZW. Again, these two have a common attribute. What is the common attribute for these two, sir? Y. What is the closure of Y? Y. Then Y implies ZW. Anything else? No, sir. Anyway, we got R4. So let us combine R1, R3, R4. P, Q, S, Y, Z, W. What about R2, PX? Sir, please observe it. Is there any common attribute? No common attribute. So that means R1, R3, R4 intersection of 2 is equal to empty. Sir, what is the clause of empty? It is empty only because with 0 details we will get 0 details only. So it is loss. Hope you understood it. So in the given example, D1 no loss, D2 there is a loss. Hope you understood it. Yes, sir. This is about for today's session. In next session, we discuss about dependency preserving decomposition. Thank you.